In your NCRT, are you having NCRT in front of you? Samya, Sal? Yeah, you are having. So, can you let me know how many exercises are there? Exercise 1.3 is there.
Yes, ma'am. Ma'am, 5 exercises are there.
Ma'am, five.
Okay, 5 exercises there. Just a second. Okay, so the next one is real number. And their decimal expansion. Suppose we are having a fractional number like 10 by 3. Okay. Or maybe a fractional number 7 by 8. If we have to find the decimal expansion of these fractional numbers, the normal basic long division method we can apply, right? And we can see what exactly is the pattern we are getting, whether it is terminating decimal, whether it is non-terminating decimal, whether it is non-terminating recurring or not recurring, right? Samya and Shad.
Yes,
Let's divide this 10 by 3. What are we going to get? Let's do it on the screen, because this one is very like the normal division we are going to perform over here. That is 3 times 9, then 1, then decimal will give, that will give us again 1 0. Again we ended up getting 10, that means 3 times 9. So we can understand from here that every time we are getting the remainder 1 1, and we are just getting 1 0 from there. So what will be the decimal expansion of 10 by 3?
3.33. 3.33
bar. Yes, it will be 3.3 bar, because from here you can understand it will keep on coming again and again. We'll be getting the remainder as a 1 1 1 1 1 1. So this 3 3 3 3 3 3 will keep on repeating itself. Now can you tell me it is falling on which category? It is whether it is a terminating or non-terminating?
Non-terminating.
It is non-terminating. Is it recurring or non-recurring?
Yes, ma'am.
Recurring.
It is recurring. Okay, so this is how we just have to do the division, and then we have to identify whether the given fractional number, whether the given rational number, because it is in the form of p by q, it's a rational number. So whether the given rational number is, what will be the decimal expansion of that? We got the decimal expansion, that is 3.3333. And after doing the decimal expansion, whether it is a terminating decimal or non-terminating decimal. If it is non-terminating, whether it is a recurring or non-recurring. This is how we have to identify it. Now if we are having this type of question, we are also having in this exercise only, that if we are having a decimal number, 3.142678, Can we write it in the form of P by Q? If so, then can you tell me what we'll be having if we will try writing it in the form of P by Q? Yes, Samya. We were discussing it in the previous class that this decimal will be, how to write it in fraction, the decimal number. Yes, Saad. What will be having? Just remove the decimal, write the number, and then just wherever decimal is there, that will give 1. And after that, the number of digit, whatever be the number of digit, that one is 0 we have to place. Do you know that, Samya and Saad?
Yes, ma'am. Yes, ma'am.
If 2.5 is there, it will be 25 by 10. If 3.67 is there, it will be 367 by 100. So if we can apply that concept in the smaller terminating decimal number, we can apply it here also. Even if the number looks like so many digits are there, so what? We will be applying the same logic. That is 3, 1, 4, 2, 6, 7, 8 over this decimal means 1. And how many digits are there? How many zeros shall I write over here? Samya and Saad.
Ma'am, 6.
I'm 6.
6 zeros. Let me count. 1,
Ma'am,
2, 3, 4, 5, 6. Perfect. 1, 2, 3, 4, 5, 6. This is how we need to write it. Okay, in the form of P by Q. Now we have represented this rational number in the form of P by Q. This is also we have already discussed. It is non-terminating decimal number. We have also discussed the same case, how to write the terminating decimal number, like 0.235. If we are having this type of non-terminating decimal number, non-terminating recurring decimal number, which we already know is a rational number, how to write this also in the form of P by Q. These are the questions which we have already covered. Let me see what else we need to cover over there. Rationalization is something which we need to cover today. Now, if the question is like this, that check 7 root 5, 7 by root 5, root 2 plus 21, 5 minus 2. Check it whether among these number, which one is rational and which one is irrational. So, as we already know, inside the square root, if there is a number which is not a perfect square, like root 5. Root 5 is not a perfect square number. We won't be able to take it outside from the square root sign. Okay? It is a rational number or irrational number. Samya and Saad. Square root 5 is a rational number or irrational number?
I'm irrational.
Irrational. So 7 root 5 will also be irrational numbers. So you can understand from here that irrational number when we are having, and if we will divide it or multiply it or add it or subtract it by any number, whole number, natural number, whatever, if we are having one of the number as a irrational, like irrational number into any other number, any number, the result will be irrational number only. Okay. Similarly, irrational number divided by any other number, the second one, the result will be irrational number only. Similarly, the third one, irrational number, root 2 plus 21. 21 is a whole number. Okay, 21 plus 21 is an integer. But if we will add it with irrational number, the result will be irrational number. Pi minus 2. pi is an irrational number. We have already discussed. If we will subtract 2 from that, still the result will be irrational. So when you will add any other number to irrational number, when you will subtract any other number to irrational number, when you will multiply, when you will divide, the result will be irrational only. Okay. Now let me check what else is there. If we have to add this type of numbers, the simplification related to irrational number also we are having over here, that is 2 root 2 plus 5 root 3 we have to add, and square root 2 minus 3 root 3. If we have to add these two terms, these are irrational numbers, how we will be adding them? Please try it and let me know what are you getting. When we are going to add this two, what are we going to get?
Ma'am, 3 root 2 plus 2 root 3.
You got two, what you got, Samya?
Ma'am, 3 root 2 plus 2 root 3.
Yes, Saad, are you getting the same? Shad,
Um,
have you done it? Have you tried it? See, how can we do
yes,
it?
ma'am. Yes, ma'am.
Okay,
Yes, ma'am.
you also got the same?
Ma'am, same answer.
Okay, let's check. So if we have to add these two terms, both are irrational. So we'll be having 2 root 2 plus 5 root 3. Okay, plus, and means we have to do addition according to the given instruction, root 2 minus 3 root 2. Okay, so root 2, these two term are like term. The way we were adding x and x while doing the algebraic expressions, the way we were doing the addition subtraction of the like terms, here also we will see the same thing. 2 root 2 and plus root 2 will be 3 root 2. 5 root 3 minus 3 root 3 will be 5 minus 3 will be plus 3 root 3. Okay, so 3 root 2 plus, okay, wait, yeah, it will be 2 root 3. Yeah, 5 minus 3 is 2 only. Yes, it is perfect. This is how we need to do the simplification. Similarly, if we are having 3 root 2 multiplied with 5 root 2, can you tell me, Saad and Samia, what are we going to get? Yes, Saad.
30.
30 you said, Samia.
Yes, ma'am.
Shad, what are we going to get?
Ma'am, 30. 30.
Same?
Yes, ma'am. Yes, ma'am.
Yes. Whenever we will be doing the multiplication, 5 into 3 will become 15. And this root 2, when we will multiply root 2 with root 2, they both will collaborate and will come inside one square root sign. We will be having 2 into 2 like this. Once we are getting a pair, one number will come out, that is only 2 will come out. So from here we must keep in our mind that whenever we are having root 2 into root 2, the result is only 2. Whenever we are having root 3 into root 3, the result is only 3. Whenever we are having root 5 into root 5, the result is only 5. Okay. because they will make a pair and hence we'll be getting a number out of it. Now rationalization is also there. Whenever we are having a number that is 1 by root 2, and if we have to rationalize it, rationalizing means what in mathematics? No, whenever we write our answer, always, not only in this chapter, we always write our answer when we are having this type of square root number in the denominator. That is not the standard format of writing any number, be it a fractional number or whatever we are having in the denominator. We don't want this square root number. If in the denominator 1 by root 25 is there, that is fine, we can write it as a 1 by 5. But if 1 by root 2 is there, the square root we don't want to keep in the denominator. That's why if a square root term is there in the numerator, it's fine. But if a square root term is there in the denominator, this is not the standard format of writing it. So we always try to just do any arrangement over here, so that we will just eliminate, we will just be able to remove this square root sign from the denominator. Again, I would repeat, this is not only here, everywhere you will see whenever we are getting square root as a like, and we ended up getting answer as a 1 by root 2 anywhere while doing any calculation, our one more step we have to perform, that is to rationalize it. So here we are learning how to rationalize, we will be applying it everywhere. Okay, you can relate it with that concept, that once you have learned how to do the approximation of a decimal number, if 5 is there, we have to increase one number. If less than 5, like suppose we are having 3.2468, if this type of number is there, and if we have to write the decimal number like up to 2 decimal digit, what we write? We write 3.25 we write, right? Because here 6 is there, which is more than 5, so we increase one more over here. Do you know that, Samya and Sad?
Yes, ma'am.
Yes,
So
ma'am.
this concept, once you have learned and you started applying it everywhere while doing any numerical problem in the physics or everywhere, we just follow the same pattern, like we write our answer in approximated form by taking 2 decimal digits. So similarly, rationalization, we are learning it for the first time and we'll be using it now. After it, every time we'll be using it. So see carefully how we will be rationalizing it. Rationalizing means just getting rid of, we want to just get rid of this root 2 from the square root sign. For that, we have to multiply. For that, what we can do, we can, as we have understood that root 2 into root 2 is making only 2. Root 5 into root 5 is making only 5. Roots 3 into root 3 is making a whole number only 3. Similarly, when we are having root 2 in the denominator, what we can do, we can multiply root 2 and root 2 in the numerator and denominator. Now, when we are having a fraction, when you are having a fraction, multiplying or dividing same number in the numerator and denominator will not make any difference. We are not doing any drastic change, Samya and Sad. We are just doing one arrangement. When you will multiply root 2 in the numerator and root 2 in the denominator, that means basically you are multiplying with 1. That means you are not changing anything. Are you getting me, Samya and Sad?
Yes, ma'am.
Yes, ma'am.
Okay. So when we will do the multiplication, what is our purpose? What is the motto? The motto is to just remove this denominator square root term. In the denominator, if whole number is there, fine. In the denominator, if any other number is there, fine. If a square root there in the numerator, perfect. But denominator should, this square root term should not be there in the denominator. Okay, so that's why we have done the multiplication. Now keep in mind that this is the process of eliminating the square root sign from the denominator in this question. Maybe in the other question we will be using the other way of just removing the denominator's square root sign. Okay, so here we are having square root 2, here we are having square root 2. We'll be doing the multiplication. As we know, now the denominator became only 2 and the numerator is root 2. This is perfect. What we wanted to just get rid of this square root sign from the denominator. Numerator is having square root, that's fine. But the denominator should not. Okay, so we are having root 2 by 2. Is it clear?
Yes, ma'am.
Yes, ma'am.
Let's do few more questions from rationalization, because most of the time this is one of the type of question you can see, because you are just learning it, you are not used to this concept. We can see this is type 1 problem, where we will be multiplying, where the denominator is whatever is the denominator. If it is root 3, if it is root 5, if it is root 6, we'll be multiplying the same term in the numerator and denominator. Now the type 2 problem is, suppose we are having 1 by 2 plus root 3. Whenever we are having this type of question, again we will be doing the rationalization. What is the motto? What is the purpose? The purpose is to just get rid of this square root from the denominator. For that, what we can do over here, we can multiply the numerator and denominator by something. Can you tell me, Shad and Samya, what can be done over here? Yes.
Root 3 into root 3.
Yeah.
Now multiplied by root 3.
Root 3. Here,
Multiply.
when we will multiply by root 3, Shad, see, we will multiply root 3 with 2 root 3, 2 plus root 3. See, 2 plus root 3 is there. So what we'll be having when we will apply the distributive property, it will become 2 root 3, the first term, and the second term, root 3 into root 3, only 3. So yes, root 3 we have eliminated, but by mistake, like we have got, again we got one more root 3, which is not, which we don't want. We don't want any square root in the denominator. So whenever we are having this type of type 2 problem, in the denominator you will always see in this type 2 problem that there will be a plus b or a minus b type of structure will be there in this type of problem. You will always see that there is a plus b or maybe a minus b type of number or term is sitting in our question. What we have to do, we have to make the formula of a square minus b square, or the formula of, which we have discussed in the polynomial chapter. There was a formula that is x square minus y square is equals to x plus y in one bracket and x minus y in another bracket. Do you know that, Samya and Shad?
Yes, ma'am.
So we will always try to make this formula. Okay, see carefully how can we do so. So x plus y is there, we need x minus y. Okay, x plus y type of term is there. Here we need x minus y. Okay, that means 2 minus root 3 we will be multiplying. But the fraction, the rule of the fraction says that if you want to multiply only in the denominator, that is not allowed in fraction. In fraction, only one thing is allowed, that whatever you are doing with the denominator, you are multiplying with the denominator, you are bound to multiply the same term in the numerator. That is the rule of fraction, that we cannot make any drastic change. If we are writing 2 minus root 3 in the denominator for multiplication, we have to multiply 2 minus root 3 in the numerator, because eventually this is just 1. So that means we are not doing any changes, we are just doing an arrangement. Getting it?
Yes, sir.
So we will be
Yes,
multiplying
ma'am.
2 minus root 3 in the numerator as well as in the denominator. Now the numerator became 1 into 2 minus root 3, just 2 minus root 3. If a square root term is there in the numerator, fine. But we don't want it in the denominator. Now the denominator 2 plus root 3 and 2 minus root 3, what it became, x plus y, x minus y. So we can use the formula x square minus y square. That means 2 square minus root 3 whole square. If we will simplify, it will become 2 minus root 3 over this 2 square is 4 minus root 3 square is what?
Ma'am, 3.
Only 3. Can you see? We
Yes, ma'am.
wanted to get rid of this square root from the denominator, and just we did that. Okay, so this is type 2 problem, where x plus y type or maybe x minus y type of cases will be there. Our final step is 2 minus root 3 by 1. We are done with the rationalization. This is the rationalized part. Okay, so type 1 problem is where only a number will be sitting, like square root 2, square root 3, square root 4, not 4, square root 5, like that. There we have to just multiply the same number in the numerator and denominator to get rid of this square root from the denominator. In type 2 problem, x plus y or maybe x minus y type of pattern you will be able to see. So maybe this question which we did now will be like this also in the exam, 2 minus root 3. Now do the rationalization. So can you tell me, Samya and Saad, what we need to multiply here?
And 2 plus root 3.
Yes, we will be multiplying 2 plus root 3 over here, 2 plus root 3 over here. All right. And then we will get rid of this square root sign from the denominator. Okay. Let me take one more question. Please rationalize this one. 5 by root 3 minus root 5. Please rationalize it, no? And let me know what are you getting. Samya and Saad.
Okay, ma'am.
Okay.
Please do it.
I'm done.
Yes, Samya, what you got?
I'm
Ma'am,
done.
minus 5 root 3 plus root 5 upon 2.
5 root 3 plus root 5
The same
upon
answer.
2. Same answer, both have got. Let's do it over here on the screen and let's check. Since x minus y, it is type 2 problem. What we will do, we will try to make the formula of x square minus y square. So root 3 minus root 5 is there. So we will multiply with root 3 plus root 5. Okay, root 3 plus root 5. It will become 5 in the numerator, root 3 plus root 5, and in the denominator it became 3 square, root 3 square minus root 5 square. That means in the denominator it became 3 minus 5. Is it plus 2, Shad and Samya?
Ma'am, ma'am. Yes, ma'am.
Minus
Minus 2.
plus plus.
Okay, minus 2. The numerator, whatever you have found, that is perfect. But we can also apply the distributive property and we can multiply. Okay, this we can multiply to this one, this we can multiply to this one. So we can write it as 5 root 3 plus 5 root 5. This way also we can write it by 2 minus, we can write it in the numerator, or the way you have written, that is also perfect. We just want to get rid of this square root terms from the denominator. So this is how we will be doing the rationalization. Okay. Few question you will see is also can be like this one, that we are having uh, 3 plus root 2 by root 7 minus 2. You can also see this type of question. This is also still, I would say that this is also type 2 problem only. Basically, we don't have to focus on the numerator. The numerator can be anything. It can be 1, it can be 7, it can be 5, it can be any other number, it can be any other terms. That is fine. But the denominator has to be this x plus y or maybe x minus y type of terms, so that we can go ahead, we can make the formula and then we can rationalize it. Please do it, Shad and Samya.
Okay.
Second.
Are you done? Are you done, Shamya, Saad? Can we do it on the screen or you are trying it?
I'm done.
Done. What you got, Samya?
Ma'am, root 2 plus 3 upon root 7 minus 2.
Root 2 plus 3 upon.
Root 7 minus 2.
So we need to rationalize it. We need to get just this roots must not be there in the denominator, Samya. That is the purpose. To eliminate, to remove this square root sign from the denominator.
Okay.
Yes, Shad, what you got? Please give the assessment of irrational numbers today. Okay, Shad and Samya, it is already activated in your account. You will be able to give the assessment of irrational numbers.
Okay, ma'am.
Okay, let's do it over here. Let's see what are we going to get. So what we can do here in the denominator, if I focus on the denominator, I can see something looks like x minus 5. Okay, fine. So we need to multiply x plus y. Alright. So 3 plus root 2 we are having over root 7 minus 2 we are having into root 7 plus 2. In the numerator also root 7 plus 2. Okay. In the denominator it is fine. A minus b, a plus b or x minus y, x plus y. It became x square minus y square. The numerator, what will be there in the numerator, that only we need to do the simplification over here. So with the help of this question, I am also trying to explain that how to do the simplification which we are having in the numerator. Okay, this type of simplification how we'll be doing. However, the denominator is quite simple. Root 7 square is what, Shamya?
Ma'am, 7.
Only 7 minus 2 square is 4. 7 minus 4. We got 3 in the denominator. That is fine. We are going to learn now how to simplify the numerator over here. If a square root term is there in the numerator, that is completely perfect. That's what is the meaning of rationalization. Rationalizing the denominator means we want to get rid, we want to just eliminate, remove this square root sign from the denominator. That's why the instruction will be rationalize the denominator. Okay, so 3 plus root 2, root 7 plus 2. Here we will be applying the distributive property. So you must have learned in the previous class one concept, that how to multiply binomial with binomial, how to multiply monomial with binomial. Have you learned that concept?
Yes, ma'am.
Same concept we are going to apply here. Okay, so first we will pick first term from the first bracket, and then we will multiply it with whatever it is there in the second bracket. With each and every term we will be multiplying this 3. So we will multiply this 3 with this root 7. So it will be 3 root 7, because we cannot do the multiplication. One is a whole number, another is a another is an irrational number. So this is how we need to write it when we will do the multiplication. 3 into root 7 became 3 root 7. If we will multiply it with the second term 2, 3 into 2, that is plus 2 we are multiplying. 3 we are multiplying with plus 2. So it became 3 into plus 2, that is 6. Okay. Similarly, we will be doing the multiplication of root 2 and root 7. Now the job of 3 is done, because we don't have any other term. Now be careful here, only I am trying to explain that if we will be having more terms in the second bracket, the way we are doing the multiplication with 2 terms. Similarly, we will be doing the multiplication if 3 terms, 4 terms, 5 terms, 6 terms is sitting in the second bracket. Are you getting me?
Yes, ma'am.
Yes, ma'am.
Now 3, the work of 3 is done. Now we will pick this plus root 2, the ticked one. Plus root 2 we will pick, and we will do the multiplication of plus root 2 with root 7. We will do the multiplication of plus root 2 with root 7. You understand that whenever square root 2 numbers are there, both can collaborate and can sit inside one square root sign. We will be doing that just now. Now the next one, can you tell me what will be the next term, Shamya? We multiplied this root 2 with this plus root 7. Now we will multiply this root 2 to the next term also. What will be the next term,
4.
Saad and Shamya?
And 2
4 root 2,
2 2
2 root 2. Perfect. Okay, so what are we going to have? We are going to have 3 root 7 in the numerator. We cannot do anything. Plus 6, we cannot do anything. Root 2 into root 7. Both can sit inside one square root sign. That means 2 into 7 they can make. Still we are not getting a pair. No worries. We will multiply and write it as it is. Root 14 plus 2 root 2. Now we cannot simplify this numerator. This is what we are having. So in this chapter, you are having this type of simplification also, where you have to do the multiplication like this. One by one, the way you were multiplying the binomial with binomial, same way we have to do the multiplication over here. Let me tell you how you will be having the question. The question you will be having like this one, that if we will multiply 3 plus root 3 with 2 plus root 2, what we will be having? The instruction is to simplify it. Please let me know what are we going to have over here, Samia and Shad. the first one, and the second one is root 5 plus root 2 whole square. Yes, you are doing it right. Shamya,
Yes,
start.
ma'am.
Yeah, do it.
Yes, sir.
Ma'am, done.
Yeah, what you got, Samya?
Ma'am, 6 plus
I'm done.
3, 2 plus 2, root 3 plus root 6.
6 plus 3 root 2
Plus 2, root 3
Plus root 3 plus
plus
root
root 6.
6 plus root 6.
Let me check. 6, 3 root 2, 2 root 3, root 6. Yes, this is how we have to do the simplification. Please do for the next one also. Check it whether we can apply. We can also do the multiplication, but here we can also apply the identity. Please apply the identity.
I'm done.
Yes, what you got, Samya?
Ma'am, 7 plus 2, root 10.
7 plus 2
Root 10.
root 10. Yes, Shad, what you got?
The same answer. 7 plus 2 root 10.
Let's check. Root 5 whole square a square or x square plus 2xy plus 5 square. 5 square, root 5 square is 5, root 2 square is only 2, 5, 6, 7. Yeah, this is what we are going to get. Next one. Now the next concept is law of exponents. Let's understand it. Okay, what does the law say? We will be solving questions from law of exponents in the next class, but what few formulas, few rules we are going to take today. So the first rule is whenever we are having a to the power m into a to the power n, it will be a to the power m plus n. Okay, Please don't get confused with this A and M and N. I'm going to give example, and the example is if we are having 2 to the power 3 into if we are having 2 to the power 5, we will be having, like, the bases are same, both are 2 powers, can be same, can be different, doesn't matter. If it is m and different numbers, perfect. If it is same number, that is also fine. We just have to add them. So what we will be having as a result, it will be 2 to the power 3 plus 5. That means 2 to the power 8 we will be having. Now if you want to apply the basic knowledge which you are having from this, that is, if we are having 2 to the power 3, that means 3 times 2, 1, 2, 3. If we are having 2 to the power 5, that means 5 times 2, 1, 2, 3, 4, 5. Let's count it. How many times 2 we are having? 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2 we are having. That's why we are getting this result over here. So this is the concept, but always we will apply the formula. Okay, the formula says that whenever there is a multiplication between the same basis, power can be same, can be different, doesn't matter. If we are having 3 to the power 2 into 3 to the power 2, still I would go and will do the addition of the power
3
because
to the
the
power
bases
4.
are same. Okay, it will be 3 to the power 2 plus 2, that is 3 to the power 4. So now you can understand that when the bases are same and when the terms are in multiplication, when the bases are same and when the terms are in multiplication, we have to add the powers. Multiplication, same base, add the power. Okay, when we are having multiplication between the terms, when the bases are same, we have to add the exponents. Now this is the first rule. Now the second rule is, whenever we are having a to the power m over a to the power n, okay, like this one, or we can say a to the power m divided by, or we can also write it as a to the power m divided by a to the power n. If this way we are having, then the result will be a to the power m minus n.
9 to the minus.
Okay. Now again we will see the what is the concept behind it. Then we will be taking few questions from here. So the concept says that whenever we are having 3 to the power 5 over 3 to the power 2, that means how many 3's we are having in the numerator? 1, 2, 3, 4, 5. How many 3 we are having in the denominator? 1, 2. 2, 3 will get cancelled out, and how many 3 will be remaining? This 3 times 3, that means 3 to the power 3. And what the rule says? The rule says whenever we are having the same base and when there is a division between the numbers, between the terms, then we have to subtract the exponent. So here we will be subtracting the exponent. Here we will be subtracting the exponent, and then we will be getting 3 to the power 5 minus 2. That means 3 to the power 3. Are you getting it, Shamya and Shad?
Yes, ma'am.
Yes.
If you are getting it, please let me know how to do this one. 8 to the power 5 into 8 to the power 7 will be what?
Ma'am, 8 to the power 12.
Okay, 8 to the power 12. Is it so, Shamya?
Yes, ma'am.
Perfect. If we are having 7 to the power 5, what are we going to get?
Ma'am, it will be 7.
It will be only 7. We have to do the subtraction, that is 6 minus 5, that became 1. 1 we can write or we can avoid. It's the same thing, right, Samya?
Yes, ma'am.
So this two formula is clear to both of you.
Yes, ma'am.
Okay, let's take the other few more laws we are having, few more rules we are having. Let's take it. So the other rule is whenever we are having a to the power, the third one, whenever we are having a to the power, we can say it's m, we can say it's p, q. Basically, you just need to understand. Okay, so if we are having a to the power p and then one more power is there, then we have to multiply the exponents. Okay, if the same base is having two different exponents, then we have to do the multiplication between the exponents, so it will become p into q. Let's take one example. So the example is whenever we are having 2 to the power 3 and then one more exponent we are having, let's say 2, then we have to multiply the exponent. This 2 exponent will get multiplied with each other. So we will be having 3 into the power 6. All right. Let's see the concept behind it. So the concept is whenever you are having, concept is whenever you are having, let's say 5 square and then power is 3. Okay, that means whatever is there inside the bracket, that is 3 times. Okay, so whatever is there inside the bracket, that is 3 times. What was there inside the bracket? Inside this circle, 5 square is there inside the circle, that we have to write 3 times. Yes or no?
Yes, ma'am.
Yes,
That is
ma'am.
the meaning of this power 3 outside, right? That is the meaning of this power 3 outside, this one. We have whatever will be there, repeat it 3 times, multiply it 3 times. We have done the multiplication 3 times. Okay, so we have done the multiplication of 5 square, 5 square, 5 square. This is just the concept we are discussing. Okay, however, we will be applying the formula every time, the law every time, law of exponent. Okay, so now this 5 square means what? It means 5 into 5. This 5 square means what? It means 5 into 5. And what about this 5 square? This means 5 into 5. So how many 5s we are having? Check it. How many 5s
Ma'am,
we are having?
6.
Mia and Saad?
6. Ma'am, 6.
6.
Times. So we can write 5 to the power 6. What the rule says? The rule says whenever you are having two different powers, please do the multiplication of the power to save your time. Okay, getting it?
Yes, ma'am.
Yes, ma'am.
Okay. Now, one of the rule is like this. A to the power 0 is 1. Anything having power 0, that means 1. Any number having power 0, that means 1. Any term having power 0, that means 1. Any term having power 0, that means 1. Okay, a plus b to the power 0, that means 1. So power 0, exponent 0 means it doesn't exist over there. The result is 0? No. Be careful, the result is not 0. The result will be 1. So any number, 1000 to the power 0, 1. 100 to the power 0, 1. 32 to the power 0, 1. X to the power 0, 1. So whatever you are having, if the exponent is 0, that means that term don't even exist.